So today we're going to be going over the data analysis for the gender discrimination project, and I'm going to be answering these 4 bullets. Okay. On the right hand side, I have a statistical analysis software open called RStudio, and I have the data set listed here. Okay. Right now, this head command right here gives me a little bit of a snippet of the data, and it's displayed right here. Okay. So here's a little bit of snippet. I have the variables base salary, sex, seniority, age, education, and experience. Okay. Now salary 77 we're going to ignore. It shouldn't be used to predict base salary because the base salary, salary 77 and your starting salary are related. So we're just going to use these 4 variables. Okay. Now, I'm going to provide you with the code, and one of the things for the code that you might find interesting if you have R or RStudio is that will be a command. This command right here, it brings up the data description. Okay. And in order to load in this data set, you need to have those 2 lines. So you need to install the package where the data lives, and then you need to tell the computer to initiate the library. Okay. Now, I will point out, this is a real data set from a bank that consists of 32 male employees and 61 female employees that were hired between 1965 and 1975. If you want more information on this, you can consult either this source where the data set lives, or here at the University of Chicago Graduate School of Business. Okay. So I'll go back up here. The first thing that we're asked for in this Word document is to make a box plot. Okay. So I'm going to do that. So base salary is going to be starting salary, and I want that to be based or grouped by males and females. So this is the box plot. I'm going to reconfigure some stuff. YLab, I'm going to, instead of it being BSAL, I'm just going to put starting salary. Okay. And let me give you this box plot, so I'll copy this to the clipboard, and sure, I'll just take it as it is. And the big thing that I want you, I need to copy the plot. Big thing that I want you to be able to answer here is this question. Does this indicate a pay gap between men and women at this bank? So I'll put that in bold and italics because I have not answered that question for you. All I've done is I've created the box plot. So here I'm doing the analysis for you, but I'm not doing the interpretation. I really want you to give the interpretation. Okay, so something that would be able to determine if there is a difference between male and female salaries is a t-test. Okay, so the question here is, hey, it looks like, I could compute the average or the median, and it looks like the median, which is given in this bar of the box plot for males, is higher than that of females. Is this difference in salary, is that due to random chance? Or is there a true difference, a statistical difference, a hypothesis test that we can perform that says there is no difference or there is a difference? So I'd like you to write down and state within the context of your paper why a t-test would help answer this. Like, And you might refer to like, what is the null hypothesis? What's the alternative hypothesis of the t-test that's being performed? And let's create a confidence interval. Okay, your confidence interval will help answer the question, how much is the pay gap, and provide how much or how big is the pay gap, and provide a numerical estimate for the difference. Okay, well, if I want to do that, I can do a t-test just by doing this. So I'm going to see if there is a difference in starting salaries between men and women by performing this t-test. And here's the output for the t-test. I'll copy it for you so you can comment on it in your own analysis here. And one thing that I would pay special attention to is in your t-test, this is the p-value of your hypothesis test. I'm not going to tell you what the hypothesis test is. That's something you should know. Okay. This may help answer some of that. Okay. Then it asks for a 95% confidence interval. And two other pieces of information that you might find useful is this. Okay. It gives you the mean salary for women or females. It gives you the mean for males. So the mean for females is 51.38. The mean for males is 59.56. Is that difference due to random chance? Well, this p-value helps answer it. This p-value is 3 times 10 to the negative 7th. Okay. The 95% confidence interval says, hey, 95% of the time, you would expect the upper estimate for the pay difference to be that men make $10.99 or about $1,100 more. Or it could be as little as $536. Now, one thing of interest here is, $1,100 doesn't seem like that much, but hey, between 1965 and 1975, I think that's what it said, yeah. How much money would that be in real terms to us? Is that a small amount? Is that is that like, oh, I'm gonna buy you I don't know. Is that a month's rent, or is that significantly more if we convert it into today's worth? Okay. Okay. So, you're not done interpreting this analysis. I want you to write about this analysis. Explain the meaning of this output. I gave you the output. I want you to explain to me what it is. Okay. Now, this question asks us to develop the best possible model, multiple linear regression model, and not to use salary 77. And then it asks us to comment on the quality of the model. So, there are many different models you can form. I'm going to run this head command. I can try and predict this starting salary, B cell, based on any of these 4 variables. I can use seniority, age, education, experience. I want you to include whichever ones you want in your model. You can include them all. The idea here is, hey, it looks like there is a difference between starting salaries for men and women, but maybe it's because the men have more education, right? And the women don't have as much education. Or maybe it's due to experience. Maybe the men are highly experienced and the women aren't. Maybe it's due to the fact that they're more senior in the company and the women aren't. Could it be? So the idea is, I'm going to try and take this into account in a model, and so I'll call this model is going to be a multiple linear regression, so I need this command, lm. And it says, let's try and take into account how much seniority, age, education, and experience should affect someone's starting salary. So let's come up with an equation that models how you would predict a starting salary based on these four variables. Okay, well this tells it to us. This tells us how we would calculate starting salary. Salary would be determined, well, even if they had no seniority, no age, which doesn't really make sense, no education, no experience, they would have a salary of $58.79. Okay? And there is no argument of gender here. So this is part of the output that will help you to answer this question. I'm not going to go over all of this output. This should be formatted a little bit better. And then here's the corresponding p-values, meaning that the variable is important for regression. So let me highlight some things. So we have the coefficients of the variables. These are important. Okay, and these are important for you to write down your regression equations. So something I expect you to be able to do is to write down your regression equation to form a prediction of what someone's starting salary should be for these values. Okay. And here, this one's saying that age is not significant. That's a good thing, meaning that we could exclude it from our model. It wouldn't be important for trying to predict someone's starting salary. And the reason why this is good, that this is not significant, is because if it was, that would be saying that age discrimination is a real thing. I'm glad that this bank isn't guilty of that. So you could leave in the variable age, or you could take it out. If you were to take it out, you'd need to recalculate your model coefficients with it excluded. So for now, we'll just leave it in, and we'll try and say, hey, these are the variables that account for it. And then let's try and take in an account for sex, the gender of an individual. Now, the idea for sex is if the bank isn't guilty of gender discrimination, well, then that variable should not be significant. And how you judge if something's significant, I'll put it in red, is based on these p-values. So everyone that I've marked is significant at the 3-star level, and this one's only significant at the 1-star level, so the 1% significance level. Okay, and these are the significance codes right here, down here. Okay, so all of those variables are significant. I'll leave in age because maybe it is important, and there just wasn't enough data to conclude that it was for the statistical model to know that it was actually significant. But we could drop it or not. Okay, that's up to you. So if you have access to R or another statistical analysis package, you could run a multiple linear regression without age. Okay, to limit the output of this, I'm not going to do that. Okay, so let's do a model, but now we're going to have sex in it. So I'm going to have this very same model, But now I'm also going to have the variable sex. And let's see the significance of this variable sex on the regression model. So this is going to be our model here. Let me copy and paste this because you'll need it for this very last question. So the idea here is, in this bullet point, I developed my best possible model. I said my best possible model was to exclude all these variables. It was questionable if I should include age or not, but I did. We didn't comment on the quality of the model yet, and I didn't state the regression model. I didn't state the equation that I used here, so this is left for you to do. So this is unfinished. Okay. Now, I'll write down, now in this next part, we take the model that we considered in the previous bullet point, and we add gender to it. And this is this model. Okay, if we ran with the model that we used, this would be the model with gender added. Okay. So let me format this a little bit better. Okay, then that's the standard error. Here's the t-value. Then here's the p-value, and that part's really important. Okay, so let's go through this model. Here's, if I'm to write down the equation estimates, these coefficients, these estimates are going to be really important. Okay. So this is involved in writing down your equation. Okay. Something else that's going to be useful is this r squared. Okay. Now, I mentioned the statistical significance is determined by this variable right here. That one's statistically significant, and this one's statistically significant. Age is not. It became less when we added sex male. Experience became insignificant, and that's because it's correlated here. That sometimes happens. But now I want you to look at this. Despite the fact that I had all these other variables, seniority, age, education, experience, sex male being true was statistically significant. And the idea here is that none of these other variables could account for the difference in determining starting salary, base salary, and could explain away the variable of sex. So that cannot be excluded in your regression model for predicting starting salary. Okay, the fact that that is statistically significant is one of the main components in this analysis, is that none of the other variables can explain the difference. If this variable turned out not to be statistically significant at, the 5 times 10 to the minus 8th level, then the idea is if this wasn't significant, then these other variables would explain a possible reason for why there is a difference in average starting salary for men versus women. Okay, so this is one more, if you will, piece of evidence that sex male is important. Now here's another one. This model right here does not have sex included in it, and its multiple r squared, the amount of variation which it explains, is at best 31.7% of the data or variability. This model, just by including the variable sex, it bumps up the amount of variation or data which this model explains, and it just has one more variable in it. It jumps from 31.76% to 51.5%. That's a lot of data being explained in the variable, and it comes from adding this one variable. Now I'm going to note one thing. Sex male is a variable that has a value of 1 if the individual is male, or a value of 0 if they are not male. Okay, and since, that would mean in effect that there is a female, that they're female if it's 0. And this is telling you the size of the increase in salary, okay, which is $767.91, just by having sex male be true. Okay. Now all these other variables here, they are numerical variables, but sex male is true or false, so it's 1 or 0. 1 being true, 0 being false. One thing that I'm going to note just in the previous model is state your regression model in the form of an equation, which has not been done here. Is not a copy and paste job of this output. This is the output. I want you to write down the equation for starting salary equals an intercept, a minus 22.58 times the seniority, etc. And I want you to know how these estimates form your equation. Okay. Now, if you were wondering about the hypotheses of linear regression, if you wanted to comment on them, I don't think that they were explicitly asked for. But I did ask for the quality of your model. One measure of quality is this multiple r squared. If you really want to go through and have some extra analysis, like you could talk about the assumptions. Okay. And one of the assumptions is normality. Okay. And normality, we could assess this through the histogram of the residuals. Okay, so let's make the histogram of the residuals. Let me format this. X lab equals X And then I'll export this to the clipboard for you. Okay. So here you can make your conclusion based on this histogram. Okay, here's another. It's the equal variance. So model which, and I only want one of the graphs, so that's why I put the which. The question is the spread of these points roughly the same as the fitted values increases? So let me export this and we'll copy this to the clipboard. And this red line can be deceiving sometime. And then the third one is independence. Is one outcome affected by the other? Okay. So these are the three things you need to assess. If you want to do that again for this model, that'd be great. So I'll give you the output. And here it's model.sex. And so the assumptions would be 1, normality, 2, equal variance, 3, independence. And you have to make conclusions of these assumptions based on these graphs. So I'll copy this to the clipboard. Here you go. Let's do this plot model.sex, and I want this one. So does this look to be roughly constant in its spread of the points as the fitted values increases? You'll have to be able to judge that. And you know, sometimes the assumptions are not completely true and not completely false. It can be like weakly violated, or it could be weakly violated, you know, rather than just straight out wrong. You know, it's more of a spectrum of, it's not true false, you know. In independence is the last assumption. So this is the data analysis you need for your project on gender discrimination. This is not a complete solution set. This is just the output. You need to fill in and write about what these values mean. You need to, in the context of the data analysis, and here, for example, you need to write down what your model is in both instances. And I'll be really grading you on these details of the writing, explaining it, in the bullet points that were questions that I did not provide for you. I'm expecting you to fill in. I will grade you on that. Okay. Well, I hope this has been helpful, and thank you for joining me. Bye.